Hey guys, welcome to this Hero Talk episode of the Plumbers of Data Science podcast. I'm your host, Andreas, and this is an episode where I talked to Paolo Lulli. He is a data engineer with a lot of experience with API development, industrial Internet of Things, machine-to-machine communication, and so on. And we were talking a lot in this episode about how to host your APIs. The best infrastructure, is it serverless? Is it getting servers? We were also talking a lot about time series databases and the different ways of hosting or storing your data. We were talking about vendor login and so on. So super interesting episode. I hope you have fun and let's get into it. So yeah, let's just chat, Paolo. Nice that you're here. Thanks for scheduling this meeting.
Thank you for having me.
I always try to talk in these podcasts with people that are in the business, that are actually working on engineering problems, and so it's cool to talk with someone who's actually doing the work.
Yes, that's the same. I find a lot of things that you put out very interesting, and I actually love the plumber word that you throw in because that really resonates with me. I'm mostly a developer. I've been working as a developer in 2 decades. And I shuffle a lot of data around, but I'm not really a data scientist. So I'm more of a plumber, really.
Can you say a few words about what you're doing right now, what you're working on?
Well, I'm basically working on an industrial IoT gateway receiving end. And it's been the case for the last couple of years. I mean, it's a niche that I basically have been following the last couple of years.
Yeah.
And
Does that mean that is a hardware device where you make basically the couple between device and internet, or how is that?
no, I solved the problem of receiving lots of data from different, huge number of devices. And it just happens to be the case in the last couple of projects that it's cars, but it could be some other kind of device.
Cool. Because what I've been working on is I was also a long time in the IoT field. For me, it was like machines in plants, or we also had ships that were sending data, or drilling rigs and so on. So, but back in the day, we called basically the gateway. We called that the device that actually makes the transition for the data, that records the data locally and then sends the data out to the platform.
Yes,
And
yes. I'm
I
more on
was
the receiving end. Basically.
I was basically responsible for the platform to then get the data in, do all the work on the pipelines for the processing and so on.
That's interesting as well.
Do you have found some interesting things with APIs when you build APIs for, I'm guessing, large fleets?
Yeah, that's the main focus, I would say, building APIs, building, maintaining, perfecting, because building APIs nowadays is kind of very easy. All main programming languages make it easy to create APIs, but then you need to maintain them, and you need a real backend that sustains them. So you need to structure the data in a certain way, and you cannot just improvise, so to speak. And there is, it's a very layered approach. I guess everyone is on top of some other giants, like from the hardware level to the communication to the gateway, and a lot of cloud computing. It looks like it's a strange scenario because the same kind of activity depends on the platform that you are using. If it's Azure, if it's AWS, it looks like different skills, but it's actually not. So yeah, it's an interesting scenario.
These platforms, especially when building APIs, they were kind of the same. And
Yeah. But there's a lot of different way that you can do that. I mean, the traditional implementation, you deal with the load balancer and real servers, while in AWS you can just spin up a Lambda function or something like that. Or I think we're not really doing life easy on ourselves with lots of different solutions that solve the same problem, but in a different way, like the serverless way, the traditional way, and then there is the brand AWS, brand Azure, brand Google, or IBM, or whatnot.
But what's your favorite way to basically process or have the backend of the API, the processing of the API? Are you working, or do you like more the serverless approach or more the approach with servers?
Myself, I like the idea, kind of like the self-hosting approach, because I'm extremely, I grew wary over time of solutions that you implement, for example, in AWS, and you think, okay, I govern the business logic. So if tomorrow I need to port it somewhere else, then I can just I reuse business logic and then just change the plumbing. But that's not really the case. It turns out that 90% of the work goes into the plumbing. It's not the business logic, the heavy part. So actually, I grew up pretty wary about vendor lock-in. I think we're increasingly binding ourselves to specific solutions that are solved problems in the literature, for example. But once you marry one of those platforms, you're basically stuck with it forever or for the life of the solution itself. So, I mean, what I like is not necessarily what happens in this industry because, of course, big players have a budget and they have a schedule. They need the solution in 2 years, 1 year, 6 months, whatever. And the tools are basically the one provided by the big hyperscalers. So you can just build and fit in your business logic. But I think long term is not really an optimal solution because you end up re-implementing the same things over and over. That's
I mean, I always see it like the upside of doing this. Let's say you're on AWS, you're using API gateway, and you're using a Lambda behind. It's very easy to set up. It's also quite easy to scale because like you don't have to, like from the setup wise, you don't have to worry about any updates or maintaining the systems. But like, is it really cheaper than hosting it? Like also for like message queues
no,
and stuff?
no. Of course, it's not. It's not. It's much more expensive. I mean, self-hosting things can be very cheaper, very much cheaper, but you need the competencies and you need the maintenance and you need the effort. But I think it's a matter of not scale, but focus maybe. So depending on the company, if the company is not really in the software development industry, it's just a service that you want to build, then understand that people doesn't want to focus on maintaining services and having SRE people running around the clock to fix things up. But you pay for it, and also you pay for it now, but you're also committing to continue being locked into certain service. It's a difficult word.
Yeah, I know. I mean, that's why there are also these tools like Flask, like Fast API, and so on, where you can easily create APIs, where you can host them easily. As you said, if you have the manpower for it, and
Yes.
they have the knowledge of the things or the competences, then it's a thing. But I don't know, for startups, is that really?
Um, yeah, maybe startups are like, this corner where they have small manpower and they need to iterate quickly. So that's that's probably the area where it makes more sense. But as a startup, I'm not sure. You probably will think about 10 years from now. So maybe you can get everything serverless, no load balancer, no nothing, only business logic. But in 10 years, maybe what you pay for lambdas and Lambda is extremely fun because you say, okay, I only pay for the microseconds of execution in a day. That can be like, I don't know, I pay for 20 seconds this day instead of having a full-fledged server running all the time. But the point is, then you have the problem of the cold start. So you call the Lambda in slow, then you end up, there is some parameters that basically they call the Lambda for yourself, but you still pay for it. And also, I think we need to keep in mind that what the provider charges us is not that they do on and off computing power when we call the Lambda. It's always there. It's just that they pack multiple clients, multiple customers on the same hardware. And basically, we are the ones paying for it, and they need to make profits. And I think it's extremely costly. Here, there is some unicorn, so to speak, they're trying to push for an open serverless, but that's extremely complicated. You have a solution where basically you have something that can be deployed on Kubernetes, either locally or on in AWS, AKS, Azure, or maintain the compatibility. So it's extremely complex solution to maintain the serverless simplicity on the developers' shoulders. I am, on that I'm extremely opinionated because I think whatever is your preferred programming language, being Python, I have a long experience with Java, Golang recently, but really any programming language you can set up a service, and then whether you containerize it or not with Docker, whatever. But you can use a load balancer like spin up an HA proxy. It's a fantastic open source solution, and that's what they use in the hyperscaler. So, and the knowledge is there. I mean, it's open. You can see the code. You can configure it yourself, and I think it's an investment looking at those building blocks, so to speak, like the load balancer. Of course, container orchestration is a very tough area.
Like, how are you afraid of the topic of scaling with this when you run it? I mean, when you run hardware, when you run, when you host this yourself, like how afraid are you of this?
I'm not afraid. I think it's an area where there are a lot of opportunities because, for example, you can rent a physical machine, and then in comparison to, I don't know, paying for a VPS or something like that, you can buy a physical one, and then you think, okay, I get 64 gigabytes of RAM. What can I do with that? And the simple math would be, okay, 64 gigabytes. That means if I have virtual machines with 2 gigabytes, then it's 32. But it doesn't work like that because maybe those virtual machines are idle. So memory-wise, you can stuff way more than you think. So it's not 2 plus 2 makes 4. It's like 8 plus 8 makes 4, or something like that. And if you look at it in reverse, that's what AWS, Azure are doing. So they basically sell you 16, but what they actually have as a cost is 2. So there is a lot of opportunities there. But of course, you need to balance that with the knowledge that you need, and also the maintenance. I mean, maintenance is not free, of course. But a startup, for example, that has knowledgeable people that can set up a system that can run for a very long time, they can save a ton.
But where are they putting the service? So they're also renting these from somewhere, right? Or do they have a data
Yes.
center where they put this in? I don't know.
I mean, the real self-hosting means that you have your machine and you rent the space in some data center. That's extremely hardcore, someone would say it. But there's a ton of providers, especially in Germany, I would say, that rent physical machines. And yeah, again, I see an area where there are opportunities.
I remember back in the day where we did a lot of machine learning on top of NVIDIA GPUs. And we were just getting large computers with GPUs in them. I don't know. I don't remember how much one of these computers cost, like 10,000 or something. But when you calculated it that they were running 24/7 and they were doing analysis, and then when you calculated against AWS, what you would have paid on AWS, it was super cheap.
Yeah, I mean, I heard someone who had unfortunate circumstance of making the mistake of pushing some private key to some repo, and it happened during the night, and the morning after woke up $100,000 poorer. So it's very, you can spend $10,000 in AWS. You can spend them very easily, I think.
That's
So,
true.
of course, that's not to encourage anyone to push API keys to repo, but so probably you think very hard before buying that much of equipment, but you still have it, you own it, and if it's too much for yourself, you can sell it. You can rent computing time, whatever. Yeah.
It's an interesting thought, because like a lot of people recently, they're just on the we're doing everything serverless path,
Yeah.
and that is the best way.
Yeah.
But as you say, like,
Yeah, I think there is the sweet spot. Like if you have the right combination, your Lambda is called once a day, twice a day, and then you're overpriced, but still you save a lot, and in sanity of mind, not to have to maintain a solution. So that I understand, but it's an extremely rare trade-off. Also because when you build services, I mean, as a developer, you want more people to use it. While with Lambda, you have this incentive to not use it. So,
of course, because you're paying more if it runs more often, right?
So it's a strange mindset.
Interesting. But like when you host it, then, or when you self-host it, you need to have good monitoring on it, right? You need to have.
Yes.
You need to make sure that there are no spikes throughout the day that actually crash your system because you
Well,
don't have enough resources.
monitoring is another very interesting corner, so to speak. Because, for example, former client, they had again an IoT system. I don't want to enter into detail, but basically they had those devices, let's call them, sending data. and they had over cellular connection. So and they have an estimate of the yearly cost, and they were doing things really hardcore, like I send one single UDP packet with the sensor data a day or something like that. And yeah, so the SIM card was charged like $5 a year or something like that. So really machine-to-machine connection. So and the estimate was something like that, like $5 a year. No, sorry, $5 a month, maybe, or something in total, comprising all other costs, service costs. And in the end, when they were confronting the invoices with this estimate, instead of 5, it was 35. And then they started a big analysis, investigation with everyone was clearly on its edge by trying to demonstrate. I'm not logging too much, stuff like that. I think they were using CloudWatch to basically support the SRE function. So SRE is reliability engineering. So basically someone making sure that everything works. In the end, it turns out that the widest cost out of this, this cake diagram was actually SRE engineers performing CloudWatch queries on the logs of the application to retrieve, to make sure that everything was fine. So basically, the service itself was costing 7 times less than people looking for the logs.
Okay, that's crazy.
And that's I mean, I wouldn't sleep at night if I have such a service. It's not that you're out of budget. You're 7 times
Wow.
spending 7 times more for retrieving the logs and see if the application is working. Maybe this. So the log that you find is telling you, yeah, okay, 200, HTTP 200.
So,
And,
but what's the solution to this? Move to a different system. Have like not report to CloudWatch, but create something like an Elasticsearch cluster, and then just write it to Elasticsearch or something.
I think Elasticsearch is a pretty widely accepted solution. It's quite painful to set up, I have to say. It's not a lot of fun. But yeah, that's one way. That's one way.
Because then you can make it again that you set up your own infrastructure for this, and this runs, and the actual searches on CloudWatch on Elasticsearch costs you nothing again, because you're just paying for the
Yeah, I
infra.
mean it's a fixed cost. You set it up and then, but yeah, we are assuming here that you keep like the last year, 2 years of history, because it's no longer a fixed cost if you're planning to store your full application history.
Yeah,
But
that's very interesting. Like with the IoT data, and for one machine, usually it's completely forget about it. It's not that important. But if you have a lot of machines, and you
yes,
think about storing every or basically all the data, have no retention period, it can get quite expensive, right?
yes, absolutely. Yeah, I actually grew up this small product, this yet another time series for this purpose. I haven't
Yeah.
developed it. It developed itself out of this thinking,
Okay.
because you want to be able to query hot data, but also, yeah, for some either legal reason, or I don't know, you might want to keep the entire history. And then if you log into, say, in database in a wide sense, I'm not saying, yeah, consider Elasticsearch as well as a database. That's expensive. So I think a good strategy, that's my thinking, could be some cold storage in Parquet file. They are super compressed, and I think S3 is a very good API. when I say S3, I actually like that it doesn't have to be AWS, because there is a number of providers and also of libraries that are compatible with S3. So it doesn't have to be AWS necessarily. But it's a good way to archive and also send around data to consumers over HTTP. So it should be pretty much a standard way to access things.
Can you tell me a bit more about the database that you were talking about? Like what you've created? That
Yes,
sounded
this
very
is
interesting.
yeah, this is okay. The thinking is yeah, again, it comes a lot out of experiences, different experiences where people was basically trying to reinvent in different flavor, basically the same thing. A lot of storage of data that was in the end some sort of time series. So I feel like there aren't many such tools that don't provide also some sort of lock-in. So basically, the storage engine of this solution, YATS, is Apache Cassandra, which again is not something easy to operate, I would assume, but still you can resort to having someone hosting it for you. So also again, the usual hyperscalers, AWS, Azure, IBM, I believe as well. I'm not sure about Google, but yeah, you can probably get it as a service. You don't have to install it yourself.
But isn't it like, but Cassandra, technically it's a white column store, right? So how do you then realize this with the time series? Are you putting the timestamps as the, let's say the column is the wrong word, I think.
I think you can call it column. Yes.
Yeah. Is then the timestamp and the device or the timestamp the column name, or how do you store this?
Well, in this context, at some point I was thinking that Cassandra wasn't the proper tool for time series until I encountered a white paper. It's like 3 pages from DataStax. That is basically the company that maintains Apache Cassandra. That is titled something like Apache Cassandra is awesome at time series. And yeah, I can probably link it if you want.
Yeah, send it to me.
And yeah, I will.
We can do
Afterwards.
you can do that afterwards. It's no problem.
Yeah, and basically it's a very short white paper, and basically the difficulty with Cassandra is exactly choosing the right partition key for the data and the way you aggregate. And the partition key is important because basically, for example, in the scenario of IoT devices, if you have the device ID as a partition key, then that governs the way Cassandra shards the data. That means that you can have different devices, the data from different devices spread across different nodes in the cluster. So basically, you can really grow up linearly. And instead, if you use I can't recall the exact term that it's in the Cassandra literature, but basically you use the timestamp as the key that you can use in the where condition. So basically you can efficiently go through the data without encountering any hotspot. Yeah, it's extremely technical, and it's also yeah, it is not easy. But my point being that if you follow that thinking, that is exactly what is described into this white paper, you're pretty good to go, because you can, yeah, again, allow sharding different data from different devices on different nodes of the cluster, and then everything is ordered because that's the important point when you have a distributed database, that basically the data on the node, if you search in a order that is not the one that the data is kept on disk, then you incur huge penalties. But as long as you basically partition by device and provide a timestamp, the queries are actually pretty efficient.
Hmm.
But I'm not talking about the payload, because basically here the focus is on storing this data that comes from a big number of devices. But then the content, it could be whatever at this point. Yeah, I made it a point that it's useful for distributed logging as well. So in that case, it would be structured or unstructured text data, basically. So
Hmm.
base64 encoded data. But if you're interested, for example, in a payload that is a structured log, like a JSON file or something like that, then of course what you're indexing is not the content. So you need another layer of abstraction on top of that. So Cassandra is only the raw persistence. With this thinking of I only keep the hot data on the database, because the costs there can skyrocket pretty fast, but rather swap out to Parquet 5.
So,
So,
okay. I find the Cassandra topic very interesting because actually, back in the day when I started looking into this, I had two potential data stores for IoT data. That was Cassandra and that was HBase back in the day. Because the good thing was with both of them, they were doing sorting of the data. I think basically of the keys. And HBase, it was that the key is a key value store, so the key was sorted. And this way, when you were querying data, you only needed to say, okay, this is my beginning, this is the end, and then take everything in between, right? And I'm
yes.
guessing that's the same thing that you can do with Cassandra when you
Yeah,
when
you can
query.
do it by using the proper indexes. I can go into the detail. I can share the schema of this. I think it's on the web somewhere. So,
Yeah. Yeah, send me some information. It would be super cool. We're going to share this and put
absolutely.
this in the description of the podcast. Yeah, the thing is, we only have up to 5 minutes now. I think this was a very interesting talk with like very surprising in the terms of vendor login, alternatives to doing everything serverless, and time series databases, or how to store time series data,
Yeah.
and not in a specifically built for time series database.
Yeah.
Yeah, I think it would be really cool if you sent me some information that I can share. These links we were
Absolutely.
talking about.
Yes.
Um,
Yeah,
and
I think we were talking about the Cassandra schema for partitioning by device ID, and basically, yeah, being able to get sorted data,
yeah,
and also eventually to paginate through them, because
yeah,
that's the thing.
exactly. And this way you can also, if when it's sorted, you can also distribute it then on the servers,
Yeah.
as you said.
And also the white paper from DataStax. I think I have the link somewhere.
Yeah, cool. Yeah, Paolo, was really fun doing this podcast with
Oh,
you.
that
Uh,
was my pleasure.
I think I learned a lot, and people, I think, also are going to learn a lot from this. This was super
Yeah.
helpful.
Thank you for what you are putting out, because I learn a lot as well.
Thanks.
I
Thanks.
find it interesting.
Yeah, thanks. What we're going to do is also in the description, we're going to put out your LinkedIn link so people can
Yes.
connect to you. I can ask you questions. We're also going to send out this via email once this podcast comes out. Most likely, it's already going to be next Monday. Let's see,
That's
maybe
cool.
also Monday in a week. I need to talk to the editor how fast we get it done. And then we're going to also send people to your LinkedIn there. And yeah, again, thank you very much for coming here.
Thank you. It was
It was,
a really great pleasure. Thank you,
it
Andreas.
was, yeah, it was super interesting. Let's stay in touch over LinkedIn.
Absolutely.
Okay,
Yes. Have a great day.
thanks. You too.
Bye.
Bye.